are going to deal with one of the most, you can say, that topic which will be utilized all the time in our coursework, and that is called as vectors. ठीक है? Basically the point is its use is very like it's मतलब ऐसे बोल सकते हो कि it is going to be utilized everywhere whenever you are going to whenever we are going to do any kind of chapter. हर चैप्टर में ये यूज होने वाला है ना, क्योंकि ऑलमोस्ट सारे फिजिकल क्वांटिटीज का जो पैटर्न है उसमें कोई ना कोई एक क्वांटिटी तो वेक्टर होता ही होता है ना. So to understand it in a much more greater sense, let us first understand that why this was brought. Okay, and what was the use of it. So look over here. Let's suppose if I take one, I took a pen. Okay, I took two pens. Okay, and I just place them aligned with each other. This is 1 meter, and this is also 1 meter. So by looking at the ends of it, मतलब तुम जब इसे ends को देखोगे तो तुम क्या बोलोगे? The total length of the pen is how much? 2 meters, isn't it? तो कुछ बोलो है ना. बट पॉइंट क्या है कि चलो मान लिया 2 मीटर है, अच्छी बात है, लेकिन एक केस तो ऐसा भी आ सकता है, आई कैन टर्न दिस पेन और नॉट. लाइक लुक ओवर हियर, आई जस्ट टुक दिस पेन एंड instead of considering straight, I just made that pen to be aligned with this pen at some angles. Okay, now I told you that find the length between the gaps. Now you do not have any kind of mathematics right now to find that what is this length which is present between the ends of this gap of this pen. Are you able to get me or not? So this is why our concept of vectors was brought, to understand that how to find this length, how to find this inclined length, how to find something which is varying with respect to the direction. Is that clear or not? So to understand in much more better way, we define like how to define directions, how to define quantities. This is why we told that let's suppose if I have any kind of a vector quantity. So मान लेता हूँ एक वेक्टर क्वांटिटी है ए. अनुराग सर एक खुद वेक्टर क्वांटिटी है. यस, इनके पास मैग्नीट्यूड भी है, इनके पास डायरेक्शन भी है. डायरेक्शन ऑलवेज टुवर्ड्स द कैटरीना गैप, isn't it? Hold on. Yes. So let's suppose if my vector quantity is A, okay, then it will have some magnitude, isn't it? तो उसकी मैग्नीट्यूड को हम क्या जैसे रिप्रेजेंट करते हैं? मॉडुलस ऑफ ए वेक्टर. एंड उसके डायरेक्शन को हम उसको कैप से रिप्रेजेंट करते हैं. तो दिस मॉडुलस ऑफ ए वेक्टर represents my magnitude of the vector quantity, okay, and a cap represent my. इसके माइक से बहुत गंदा आवाज आ रहा है. किसका माइक ऑन है? सर तुम बंद कर लो. अपना आदर्श आवाज करेगा है ना. So a cap represents the direction of the vector quantity. ठीक है. Now question arises that sir, how to create this direction, how you are considering this magnitude, and why this is important. So basically look over here. First thing, we will talk about this magnitude. What is this magnitude of the vector means? Now, if I have any kind of representation, then a vector is represented in two ways. First thing, it has one point called as tail, and another point is called as head. So look over here. A vector has two things, a tail and a head. Tail means the point from where the point from where the vector starts. okay, or a physical change starts, okay, and head is that point where the vector ends. Is that clear or not? And this particular length of the particular, whatever the length of this arrow is there, this length is only going to be called as the magnitude of the vector. So magnitude in the terms of graphical way means it is the length of the vector. In which way? Graphical way, not in a physical way, I'm saying. Now question arises that, sir, if I am given some kind of a physical interpretation, then how come you will define whether it is a vector change or a scalar change? So to understand that, let us take an example. जैसे मान लो मैं केरला गया और अचानक से मेरे को बोला गया अनुराग ज्वाइन ISIS। मैंने बोला ओके, लेट्स ज्वाइन, इट्स फाइन, आई वर्क विद ओसामा बिन लादेन। ठीक, तो मैं तो बोला ठीक है चलो चलते हैं। अब मैं उसामा बिन लादेन के पास गया, उसामा बिन लादेन ने मेरे को दो चीजें पकड़ाई, बोला एक तुम लो ये स्नाइपर वाली बुलेट, और एक जो है तुम लो ये ग्रेनेड, है ना, ठीक, और दोनों को फेंको और मारना है, मतलब ऐसे ऐसे क्या करना है, एक रीजन पे फेंकना है। तो ध्यान से देखो, व्हेन यू विल फायर अ बुलेट इट विल किल, मींस इट विल व्हाट इट विल डू, इसके वजह से एक पर्टिकुलर पॉइंट पे जाके हिट करेगा, है ना। तो तुम्हें जो फिजिकल चेंज नजर आएगा, यू विल सी दैट इट इज हैपनिंग एट अ पर्टिकुलर पॉइंट, इजंट इट? अरे कुछ तो बोला है ना। But a grenade, when you will see a grenade firing, you will see that the physical change is brought in a particular kind of a surrounding, isn't it? So this is how the first idea of understanding the changes in terms of scalars and vectors was brought. They told that whenever the physical change is appearing in one particular direction, we call it as vector change. क्या बोलेंगे उसे अपन? Vector change. And whenever a particular change is appearing in all the direction, we used to call it as scalar change. Are you able to get me? So this is how they first brought this idea that whenever you have any kind of a vector quantity, then I have also a vector change associated with that particular quantity. And I if I have a scalar quantity, then I will also have a scalar change associated with that particular kind of quantity. While the vector change will have its own length and magnitude in a particular direction, and the vector quantity means scalar quantity will have both vector quantity will have magnitude and direction, while the scalar will have no directions, isn't it? है कि नहीं? ठीक है? So this was something theoretical approach about vectors. Now we'll move to most important cases of it and we'll see ahead. इतना दूर क्लियर है ना? Guys, can you hear me? Is this clear or not? नरेश क्या कर रहे हो? नरेश तुम हॉस्टल में हो घर पे हो? अच्छा 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 अच्छा, ओके ओके। तोमर लंच करने चला गया, तोमर देखो कैमरा यही है। अरे तुम तो घर पे हो तोमर जी, तो फिर क्या दिक्कत है? माइक कोई ऑन करके रखो, हमको लगा कि तुम चले गए। तुमको हम तुमको हम अपने ग्रुप का मतलब वॉल्टर लेविन का दर्जा देते हैं। ठीक है। चलो अब आगे बढ़ते हैं। Let us move ahead. Now, let us talk about one of the most important kind of a vector. I'll not write all those different types of vectors, but I'll talk on a special kind of a vector which we call it as unit vector. ठीक, अब देखो, अब जैसे मान लो, तुम सोचो कि मैंने बोला कि अ वेक्टर हैज मैग्नीट्यूड एंड डायरेक्शन। तो मैग्नीट्यूड को मॉडुलस से रिप्रेजेंट किया गया, डायरेक्शन को ए कैप, बेसिकली इसे पढ़ते हैं ए कैप, इजंट इट? या ए कैप या ए हैट। ठीक, तो क्वेश्चन ये आता है कि सर ये ए कैप ये ए हैट है क्या? अब और हम डायरेक्शन को मतलब क्वेश्चन ये भी आता है कि हाउ टू रिप्रेजेंट द डायरेक्शन इन अ वेक्टर फॉर्म। ध्यान से देखो, एक एग्जांपल लेते हैं। मान लो एक रोड है बालक, ठीक है, और on that road there is a tree, ठीक, which has some branches, और यहाँ पे एक हार्दिक पांड्या बैठा हुआ है बंदर की तरह, है ना। No, Hardik Pandya was hurt in this example, and he have a telescope. इसके पास क्या है? टेलीस्कोप. वो देख रहा है कि देर इज अ सुंदर कन्या ड्राइविंग अ कार. ठीक. एंड उसको उसने बोला मीन्स उसे वो देखा इस कार को चलाते हुए, वो बोल रहा है कि दिस कार इज रनिंग एट स्पीड ऑफ 5 मीटर पर सेकेंड टुवर्ड्स नॉर्थ डायरेक्शन या ईस्ट डायरेक्शन. देखो, ईस्ट डायरेक्शन ही लिख देते हैं, टुवर्ड्स ईस्ट डायरेक्शन. अब as a common people we can see that I have two things. I have a magnitude and I have also a direction, isn't it? Isn't it? तो पॉइंट ये आता है कि तुम कैसे बताओगे कि ये मैग्नीट्यूड और ये डायरेक्शन है. तो देखो, अब वेक्टर क्वांटिटी है तो मैंने बोला कि सर ये तो इसका स्पीड है, तो मैंने बोला कि चलो एक काम करते हैं, वेलोसिटी को वेक्टर क्वांटिटी बनाते हैं. सो अगर वेक्टर क्वांटिटी बनाना तो आई विल हैव टू रिप्रेजेंट इट बाय अ एरो ऑन टॉप ऑफ इट, isn't it? And then I'll write its magnitude is how much? 5 meter per second. But question ये आता है कि तुम इस डायरेक्शन को कैसे रिप्रेजेंट करोगे. तो मैंने बोला कि कुछ नहीं, एक काम करते हैं, इस डायरेक्शन को एक छोटे फॉर्म में लिखते हैं जिसका नाम है ई कैप. समझ में आई या नहीं है बात? तो मैंने क्या किया, इस डायरेक्शन को एक फॉर्म दे दिया जैसे ई कैप. सिमिलरली अगर मान लो नॉर्थ डायरेक्शन में चलता तो मैं एक फॉर्म दे देता एन कैप, या फिर साउथ डायरेक्शन में चलता तो उसका एक फॉर्म दे देता एस कैप. आर एबल टू गेट मी? So the point is very simple that this E cap, N cap, S cap or something like that represents the direction of a vector quantity. तो ये डायरेक्शन रिप्रेजेंट कराने के लिए हमने एक मेथड को यूटिलाइज किया, बट क्वेश्चन अराइजेस दैट व्हाट इज इट रियली. तो लुक ओवर हियर, let us understand. I'll erase this diagram and now let us move to our mathematical approach. तो साइंटिस्ट ने सोचा कि जब हमारे पास इतनी सारी दिक्कतें हो रही हैं तो लेट अस मेक समथिंग. दे टोल्ड दैट यूनिट वेक्टर इज इटसेल्फ अ वेक्टर हैविंग अ मैग्नीट्यूड इक्वल टू 1 unit but pointing towards a particular direction. तो क्या मालूम चला तुम्हें यूनिट वेक्टर के बारे में कि यूनिट वेक्टर इज नथिंग बट अ काइंड ऑफ अ वेक्टर ओनली व्हिच हैज सम मैग्नीट्यूड इक्वल टू हाउ मच? 1. And they are pointing always towards a particular direction. So this is an important thing. Why? Look over here. And they told that the representation of unit vector is in sense of it is represented as a cap or a hat on top of the vector. The third point was, first I'll write all the points and then I'll make you understand. Third point was, it means that it represents mainly the direction. And इसीलिए इसका नाम बोला गया that it is called as, this implies this is why it is called as, it is called as a direction showing vector. मतलब देखो, दिक्कत क्या थी कि सर मैग्नीट्यूड तो हम नंबर से रिप्रेजेंट करते ही हैं, लाइक 10, 5, 6, 7, ऑल दिस काइंड ऑफ थिंग्स. But the problem was how I will represent my direction of a vector quantity, isn't it? So direction is itself, it means the problem with the direction was that they didn't understood that how I can write it in a mathematical form. So they told that okay, let us define mathematical a special mathematics for a direction, and that special mathematics was the use of unit vectors. They told that this unit vector has a magnitude how much? Always 1, but it will point to a particular direction. तो जैसे मान लो, लाइक लुक ओवर हियर, लेट सपोज, जैसे मान लो दिस इज माय ईस्ट डायरेक्शन, and they told that okay, no problem, east is my unit vector. So east unit vector means what? E cap. And the meaning of E cap is that its magnitude is always equal to how much? 1. Similarly, let's suppose north है, तो north को बना दिया n cap. तो n cap का मतलब क्या? उसका magnitude कितना है बालक्स? 1. But it is pointing in a particular direction or not? अरे कुछ तो बोला है ना. तो मान लो अगर कोई इसमें पर्सन जैसे चल रहा है, मान लो मैं ही इस पे चल रहा हूँ, लेट सपोज आई एम वॉकिंग ओवर हियर विद सम स्पीड 2 मीटर पर सेकंड और आई ट्रैवल सम डिस्टेंस 2 मीटर पर सेकंड. सो ऐसे लिख सकते हैं ना अपन, डिस्प्लेसमेंट इज इक्वल टू 2 e cap, that means I have traveled 2 meters along which direction? This direction. Or velocity is equal to 2 e cap meter per second, that means I have traveled with velocity 2 meter per second along the this direction. Is that clear or not? कुछ तो बोलो मैं. Yes. तो पॉइंट ये है कि यूनिट वेक्टर गिव्स अस द आइडिया ऑफ डायरेक्शन बिकॉज सी दैट इट्स मैग्नीट्यूड इज 1. तो अगर मैं इसको मल्टीप्लाई भी कर दूं किसी नंबर के साथ, तो दैट नंबर इज नॉट चेंजिंग, योर ओरिजिनल वैल्यू इज नॉट चेंजिंग, योर मैग्नीट्यूड इज नॉट चेंजिंग. But one thing is getting specified. Oh, I got my direction. I got my specific direction. Are you able to get me? Okay. So look over here. So this is why it is called as a direction swing vector. अब दिक्कत ये था कि सर चलो मान लो नॉर्थ को बना दिया एन कैप, ईस्ट को बना दिया ई कैप, बट अगर हम ध्यान से देखें तो ऐसे बहुत सारे इनफाइनाइट डायरेक्शंस हैं. लाइक अगर ऐसे ही कोऑर्डिनेट ड्रॉ कर दूं तो एक इधर नॉर्थ ईस्ट है, एक साउथ नॉर्थ वेस्ट है, साउथ वेस्ट है, ये भी एक डायरेक्शन है, ये भी एक डायरेक्शन है, ये भी एक डायरेक्शन है. सो इन अ क्वाड्रेंट आई हैव मेनी डायरेक्शंस और नॉट. So are you going to create such unit vectors all the time? The answer is no. The point was that basically we in whole physics or in whole mathematics we do not do in terms of direction. We do in terms of I j k cap, isn't it? So look over here. So they told let us create something so that a rectangular component in terms of unit vector. So point ये है कि sir we know that whole physics is measured in terms of, or whole mathematics is measured in terms of rectangular axes or Cartesian axes, which we call it as x axis, y axis and z axis, isn't it? तो अगर मान लो अगर हम एक काम करते हैं कि अगर इसी एक्स एक्सिस को यूनिट वेक्टर बना दे, वाई एक्सिस को यूनिट वेक्टर बना दे, जेड एक्सिस को यूनिट वेक्टर बना दे, तो मजा आ जाएगा. क्यों? क्योंकि एवरीथिंग इज मेजर्ड इन टर्म्स ऑफ एक्स वाई जेड, इजंट इट? अरे कुछ तो बोला है ना निरंजन, इज दिस क्लियर? निरंजन तुम माइकवा ऑन करके रखो, हमको लग रहा है तुम सो रहे हो. ठीक है. तो बोला गया कि लेट अस मेक दिस एक्स वाई जेड एज यूनिट वेक्टर. सो दे स्टार्टेड कॉलिंग एक्स एज आई कैप, वाई एज जे कैप एंड जेड को क्या बुलाया उन्होंने? के कैप. आर एबल टू गेट मी? सो वी हैव द रिप्रेजेंटेशन दैट आई विल कॉल एक्स एक्सिस एज आई कैप, वाई एक्सिस एज जे कैप एंड जेड एक्सिस एज के कैप. अब ये मत पूछना कि सर ये आई जे के कहाँ से आया. ये ग्रीक में पहले के साइंटिस्ट थे, उन्होंने किस वजह से इसका नाम रखा मेरे को भी नहीं पता, और क्यों रखा ये खुद जानते हैं. उनके उनसे मतलब हमें टाइम ट्रैवल करना होगा समझने के लिए कि व्हाई दे टू कीप द नेम आई जे के. इज दैट क्लियर? ठीक. सो look over here. They told that I cap means the length along x axis, j cap means the length along y axis, and k cap means the length along k axis. तो जैसे लेट्स सपोज आई टेक एन एग्जांपल, जैसे मैं बोलता हूँ कि एक एग्जांपल लेते हैं अपन. बोला गया कि a person walks 10 meter along x axis. तो इसको हम कैसे रिप्रेजेंट करेंगे? बेसिकली इट विल स्टार्ट फ्रॉम ऑरिजिन एंड इट विल बी शोन लाइक दिस वे और नॉट, दैट दिस लेंथ इज माय 10 मीटर. अरे कुछ तो बोला है ना, दिस इज माय वॉकिंग ऑफ द पर्सन. So I can create my displacement vector over here or not? That yes sir, displacement vector is going to be how much? It is 10 meters, but along which direction? Along x axis. So I'll just multiply with the I cap. This equation means I have traveled 10 meters along which axis? x axis. Are you able to get me or not? ठीक. Similarly मान लो ऐसा लिख दिया, person walks 10 meter along y axis. Then what you will do? You will just write that once again, sir. We know that if it is he is walking along y axis, then this will be kind of a vector, and I will call it as once again 10 meter. And but here one thing will change. So here my displacement vector will be written as 10 j cap meters. So look over here. See, both the magnitudes are same only. Previously, the meaning of these was same, that yes, 10, 10, but now it is different. It is 10 I cap and it is 10 j cap. Means I have traveled 10 along x axis, and here I have traveled 10 meter along y axis. So this was the difference my unit vectors has brought in the understanding of vector analysis. Are you able to get me or not? ठीक है. अब सोचो जरा कि चलो ठीक है, मान लिया चल लिया 10 10, बट ऐसा भी तो हो सकता है कि आई कैन, if this is x this is y, then I can travel to some kind of a point which is, can have some coordinate. Let's suppose this coordinate is 2 comma 3. Then can you create my displacement vector? What is my displacement vector? बताओ क्या होगा? 2 I cap plus 3j. तो ये प्लस साइन का मतलब क्या है कि मतलब हम रियली में ऐड कर रहे हैं क्या? हाँ हाँ, यही चीज समझने वाली बात है. देखो पॉइंट ये है कि व्हेन आई विल जॉइन द ओरिजिन विद द पार्टिकल, दैट इज माय डिस्प्लेसमेंट वेक्टर. एंड इसको बोला जाता है, इस पर्टिकुलर टर्म को, मींस द लाइन जॉइनिंग द ओरिजिन एंड द पार्टिकल इज स्पेसिफिकली नोन एज पोजीशन वेक्टर. क्या बोलते हैं इसे अपन? Okay, and it has a special representation. It is called as R vector. I'll make you understand what is called as position vector. I'll give a perfect definition after that. But position vector is something which we have to know. The point is that here, if we can see that, if I can draw a triangle over here, then you can clearly see that this length is 2 meters and this length is 3 meters. That's the meaning of point P2 comma 3, isn't it? So what is the meaning of 2 meter? That I have traveled 2 meter along I cap direction and 3 meter along J cap. That's what is my condition. That yes, I have 2 meter along I cap and also 3 units along J cap. But later on, at the initial case only, I told you that Balak, since it is a vector quantity and as the direction changes, you means it is also known that if it is this is 2 meter and this is 2 meter, then the length between the ends of the vector is totally different. So whether you add 2 plus 2, nothing is going to change because this length is totally different or not. है कि नहीं? तो इसीलिए अपन क्या करते हैं, अपन मतलब पॉइंट ये है कि जो ये जो यहाँ पे जैसे कॉमा दिखाया गया है ना, इस कॉमा का साइन वेक्टर के टर्म्स में प्लस होता है. इज दैट क्लियर? क्यों? क्योंकि अपने पास और कोई मेजरमेंट नहीं है और कोई तरीका नहीं है दिखाने का. So do not think that I'm really adding I cap plus J cap. They can't be added because they are already in different directions. Are you able to get me or not? It's not possible to add them. So this plus sign just represent that yes, I have 2 meter along x axis and also with that 3 meter along y axis. Is that clear? And that's how my position vector is created. So plus means over here addition. It's not addition. It just means that and or you can say comma or whatever physical interpretation you want to make it out. Are you able to get me or not? तो क्या ये मेरी बात तुम्हें समझ में आई कि प्लस साइन रियली में एडिशन नहीं है? सिमिलरली माइनस साइन रियली में माइनस नहीं है. मल्टीप्लिकेशन का अलग मतलब है यहाँ पे, डिवीजन एक अलग चीज है. प्लस माइनस और मल्टीप्लिकेशन इन टर्म्स ऑफ वेक्टर इज अ टोटली डिफरेंट कॉन्सेप्ट. So here 2 plus 2 is not 4. Here 2 plus 2 minus 2 is not even 0. Is that clear or not? It depends upon direction, in which direction you are considering. ठीक है? So let us consider one more example. Let's suppose if I have, let's suppose if this is minus y-axis and minus x-axis, and I travel for some kind of a point which has coordinate minus 2 comma minus 3. Then what is my vector? What is this position vector? Minus 2 I cap minus 3j cap, isn't it? तो ये ऐसे लिखा गया क्या? नहीं, ऐसा नहीं लिखा गया. It's written like minus 2 I cap, very very good, plus plus of 3 units along minus j cap, isn't it? Basically, the meaning of minus 3 is what? 3 units along minus x axis. Oh, said one. Sorry. It is okay. I wrote it perfect now. So इसको ऐसे लिखते हैं 2 units along minus I cap plus 3 units along minus j. Are you able to get me or not? So basically, once again you got that idea, sir, that minus is nothing but the opposite direction. So first thing I told you about addition. Addition is just a representation. Addition is just a representation over here. But minus negative sign represents not the subtraction but ऐसे लिख लो, negative sign represents not subtraction in vector but the opposite direction. Are you able to get me? So I told you already that plus minus have a different meanings in a vector quantity. Plus means I'm taking in the same directions, while minus and represents the opposite direction. It's not subtraction. Here 2 minus 3 I'm not doing it. I'm just considering minus as the opposite direction of whatever was originally plus. Is that clear? ठीक है, चलो आगे आगे बढ़ा जाए. तो मान लो आगे बढ़ते हैं. So look over here. Give the heading position vector and displacement vector. ठीक है. So look over here. First thing is, let us consider a perfect diagram. Okay, let us make it over here. This is x-axis and this is y-axis. You can have also z-axis, but a small z-axis. Then look over here. Any kind of a point in this xyz frame will have some coordinate x comma y comma z or not, isn't it? Then the line joining the origin and the particle P will be called as position vector. क्या बोलेंगे इसे अपन? Position vector. So what is position vector? Let us define it. So a position vector is a vector that represents the direction of particle or direction, or you can say the position vector represents the position of particle in the Cartesian coordinate system. Is that clear or not? So position vector is always that vector which is going to represent the position of particle in the Cartesian system. Now look here. Basically, one more point is that it will always join, it will always start from origin. Remember that it will always start from origin. Is that clear or not? So look over here. If I want to write r vector over here, I have x along I cap plus y along j cap and then z along k cap or not. So this is my vector which is we know as position vector. इसी चीज का नाम है बेटा क्या तुम्हारा position vector. Are you able to get me? But ध्यान से देखो, this position vector has some length or not, which we also know by the name as magnitude, है ना? So this position vector has some length which we know by the name of magnitude of the vector. अरे कुछ तो बोलो हाँ या ना? So इसके magnitude को हम कैसे represent करेंगे? If I know my vector, then its magnitude will be represented as what? Look over here. If this is x, y, z, then magnitude of the vector is given by formula root under x square plus y square plus z square, which exactly matches practically with my distance formula, isn't it? अब ध्यान से देखो, एक और चीज है कि सर आपने तो एक्स एक्सिस को आई कैप बनाया, वाई एक्सिस को जे कैप बनाया और जेड एक्सिस को के कैप, बट वेक्टर का एक खुद अपना डायरेक्शन है या नहीं है ना? और वो डायरेक्शन क्या उस वेक्टर के यूनिट वेक्टर से रिप्रेजेंट होगा विच इज आर कैप, इजंट इट? क्या मेरी बात नरेश तुमको और अदर्स तुम्हें समझ में आ रही है? आर यू एबल टू गेट मी? तो ध्यान से देखो, बेसिकली इट हैज इट्स ओन डायरेक्शन and that own direction, look over here, if I have my vector, I told you right previously that if I have a vector, its own direction is represented as a cap on it, isn't it? So if I create a position vector r vector, then it has its own direction which will be represented as r cap. So r cap represents what? The direction of, just लिख लो, the direction of position vector, or you can say that it represents, or you can say in mathematical way, unit vector along the position vector. Are you able to get me? Next point is that this r cap can be written as what? We know the formula r vector by magnitude of r vector or not, isn't it? तो ये है क्या? r वेक्टर तुमने निकाला x I कैप प्लस y z कैप प्लस z k कैप डिवाइडेड बाय रूट अंडर एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर, और ये क्या है तुम्हारा? डायरेक्शन ऑफ द वेक्टर इन द मैथमेटिकल फॉर्म. ध्यान से देखो, तो वेक्टर इज इक्वल टू मैग्नीट्यूड इनटू डायरेक्शन और नॉट. अगर हम मैग्नीट्यूड से डिवाइड कर दे तो क्या बचेगा सर? डायरेक्शन. इसीलिए यूनिट वेक्टर रिप्रेजेंट्स द डायरेक्शन ऑफ द वेक्टर क्वांटिटी. आर यू एबल टू गेट मी? मजा आया? ठीक है. तो अब पॉइंट ये है कि सर चलो पोजीशन वेक्टर आपने बता दिया, अच्छे से समझा दिया, अब ये डिस्प्लेसमेंट वेक्टर क्या है? तो ध्यान से देखा जाए, मान लो वंस अगेन एक्स वाई जेड एक्सिस, so x is represented as I cap, y is represented as j cap, z is represented as k cap. Now look over here, I can have, let's suppose if I have, means let's suppose a particle which was at coordinate x1 comma y1 comma z1, this particle traveled to some another distance, मीन्स ये पार्टिकल अभी यहाँ पर आ गया है ना, ये मान लो पॉइंट P1 था, पॉइंट P1 से कहाँ पर आया? पॉइंट P2. which is x2 comma y2 comma z2. Are you able to get me or not? See, so look over here. Basically, for these 2 points, can I just call these R1 and R2 as my two position vectors or not? अरे कुछ तो बोलो हाँ या ना. तो देखो R1 वेक्टर क्या हो जाएगा? x1 i cap plus y1 j cap plus z1 k cap. एंड R2 वेक्टर क्या हो जाएगा? x2 y cap plus y2 j cap plus z2 k cap. यही होगा ना? कुछ तो बोलो हाँ या ना. So then look over here. Basically, displacement vector is that particular vector. What is? So look over here. I'll write the definition. That displacement vector is that vector which is defined between two position vectors, which is defined between which vectors? Two position vectors. Are you able to get me or not? Is that clear? सो डिस्प्लेसमेंट वेक्टर है क्या? मतलब अगर हम ये पॉइंट P1 और P2 दो पोजीशन वेक्टर्स के बीच में अगर हम एक लाइन ड्रॉ कर दे, एक वेक्टर ड्रॉ कर दे, and since I'm traveling from P1 to P2, so arrow will start from P1 and it will go to P2, isn't it? Then this line, this arrow will be called as my displacement vector and it is represented as delta. क्या चीज से represent करते हैं इसे अपन? As delta. Are you able to get me or not? This is called as our displacement vector. Now look over here. The question arises, sir, इस displacement vector का formula क्या? तो ध्यान से देखो. Delta R is match means this arrow is pointing towards speed resultant means position vector R2 or not. So basically R2 is going to be my positive vector and then R1 since I arrived from R1 so R2 vector minus R1 vector. So you have to see the arrow. Wherever the arrow will point, that vector will be positive. Is that clear? And then the second vector will be negative. Are you able to get me? If another arrow I would have got like this way, then it would have been R1 minus R2. So displacement vector is always the subtraction between two position vectors. Is that clear or not? अब इसके बारे में मैं आगे बताऊंगा कि why this is minus R1 and why that is plus R2. Is that clear? So look over here. If I want to write the formula of delta R, what will be my formula of delta R? ध्यान से देखो. तो delta R होगा क्या? R1 vector is written like this way, R2 vector is written like this way. The question arises that can I subtract j cap minus I cap? बताओ तो. Can we subtract? Yes. I can only Yeah, we can only subtract I cap from I cap. It is not possible to subtract J cap from I cap because J cap represents Y axis and I cap represents X axis. So there are two different directions on. So it is not possible to subtract other quantities. But I can definitely subtract the vectors or the quantities along the same direction. So what it will be? X2 minus X1 I cap plus Y2 minus Y1 J cap plus Z2 minus Z1 K cap and this is called as my position vector. Are you able to get me? So look over here. If I want to find, oh sorry, delta R vector, I want to find the magnitude of delta R vector, then it is root over, once again, same process, x axis means x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Is that clear? And you know basically it has its own direction, so delta R cap is nothing but delta R vector divided by magnitude of the delta R vector, which can you can see that. Is that clear? So this was all about your position vector, displacement vector, utilization, how to represent the vector, and then its own direction, which is represented as modulus and a car. Are you able to get me? ठीक है, समझ में आया कॉन्सेप्ट? ठीक है, अब ध्यान से देखो. हम गिव द हेडिंग. ठीक है, रिजॉल्विंग द वेक्टर्स. ठीक है, एडिशन आई विल टीच यू इन द एंड. मैं अगर रिजॉल्विंग, पता है कॉलेज में मैं इतना स्लो वे में चल रहा ना, मतलब पता नहीं चल रहा है. नाउ लुक ओवर हियर. रिजॉल्विंग द वेक्टर्स. सी, basically now let us see. Let's suppose now you got to know how to represent the vector quantity, isn't it? Now you see that if I have x-axis and if I have y-axis and I have a vector over here in this xy plane which starts definitely from where? Origin. कहाँ से start हो रहा है? Origin. And let's suppose इस वेक्टर का नाम दे देते हैं. मान लो ये वेक्टर का नाम है a वेक्टर. क्या नाम है? A वेक्टर. And this vector is making some angle theta with the x-axis. क्या कितना एंगल बना रहा है? थीटा. तो ध्यान से देखो, बेसिकली कैन आई जस्ट ड्रॉ अ ट्रायंगल ऑफ दिस a वेक्टर और नॉट? बालक्स कुछ तो बोलो, हाँ या ना? Then see that is this length. You know that the magnitude of the vector is represented as this length of the arrow, isn't it? Now see that if this angle is theta, तो इसके दो particular, you can see that if this is perpendicular and if this is base, then I can relate the base and perpendicular with the angle theta and the hypotenuse of the any kind of a triangle or not. How? See that you know that sine theta is what? Perpendicular by hypotenuse, and cos theta is base by hypotenuse. अब ध्यान से देख जरा. I know my hypotenuse or not, which is my modulus of a vector. So perpendicular is what? Modulus of a vector into sine theta. And base is what? Modulus of a vector into hypotenuse into cos theta, isn't it? तो इसका मतलब क्या है कि सर this length of the triangle is given by formula modulus of a vector into sin theta, and this length is given as modulus of a vector into cos theta. अरे कुछ तो बोल, हाँ या ना? तो ध्यान से देख जरा, हमें मिला क्या एक्चुअली में? हमें मिला एक वे, and this way was called as resolving the vectors. They told that actually when I draw any kind of a vector in xy plane which is making some angle theta with the x-axis, then that vector has two hands. Okay, that vector has how many hands? Two hands, one along x-axis, another along y-axis. Okay, and the hand along x-axis will exactly match till the base of the vector, and also since this is perpendicular, I can draw this perpendicular on this line y-axis or not. कुछ तो बोल, हाँ या ना? So this length can be also drawn on y-axis, and look over here, this angle is 1 minute. This angle was theta. Then the length, then the hand along x-axis was modulus of a vector into cos theta, and the hand along y-axis was modulus of a vector into sin theta. Are you able to get me or not? Is that clear or not? And then you look over here. If I know my hands along x-axis and y-axis, I was see. The problem was if when I represent a vector, I don't know my coordinates, isn't it? I just know that yes, this is my vector, this is angle theta. I am not aware of my coordinates. कितना coordinate है हमें नहीं पता है. तो हमें ये नहीं पता ना कि x axis की तरफ कितनी वैल्यू है, y axis की तरफ कितनी वैल्यू है. But actually, if I know my vector, then definitely also I know that what is the length along x-axis and what is the length along y-axis. And then look over here. If I know the length along x-axis and y-axis, then I can write directly that a vector is nothing but modulus of a vector into cos theta I cap plus modulus of a vector into sin theta j cap. Can I write like this way or not? अरे कुछ तो बोल हाँ यार. And this is called as resolving the vectors. इसी चीज को क्या बोलते हैं अपन? Resolving the vectors. Good morning देवांश. देवांश कौन है भाई? Is that clear? ये हम लोग में है क्या? देवांश, give me your intro please. You can write from where you are. It's nice you are learning vectors in the morning, okay? He have joined online on the video, okay, on YouTube. समझ में आया? देख, मतलब पॉइंट क्या था कि अभी तक हमें पता था सर हम कोऑर्डिनेट के साथ खेल रहे थे. अभी कोऑर्डिनेट पता है तो तेरे को मालूम है ना कैसे लिख सकते हैं. एक्स मालूम है, वाई मालूम है, जेड मालूम है, तूने एक्स वाई जेड लगा दिया, बना दिया वेक्टर, है ना. बट दिक्कत क्या थी? दिक्कत तो तब आई जब हमें सिर्फ वेक्टर पता है और एंगल थीटा पता है. हमें ये नहीं पता कि एक्स एक्सिस की तरफ कितना लेंथ है, हमें वाई एक्सिस की तरफ कितना लेंथ है, ये नहीं पता. But right now we know why, in what way, or in what sense that if I have a right angle triangle, then definitely I know my perpendicular and definitely I know my base. Are you able to get me or not? So if I know my right angle triangle, then the base will be given as what? Modulus of vector A into cos theta, and perpendicular will be given as modulus of vector A into sin theta. Now, anything which is along x-axis for any kind of a vector, if the hand is along x-axis, then it will be given as that length along I into I cap or not. And if it has some value along y-axis, so that length along y-axis into j cap. So this combination creates my vector A. Are you able to get me or not? And you can see that I can prove it. You look over here. See, basically modulus of a vector has a formula what? Root under x square plus y square. So what I will get? Modulus of a vector square cos square theta plus modulus of vector a square sin square theta. तो ध्यान से देख, I can take a square common and cos square theta plus sin square theta is 1. So modulus of a vector is equal to modulus of a vector or not. So definitely our process of representing the vectors in terms of cos theta and sin theta along x axis and y axis is totally perfect because ultimately I'm getting the modulus of a vector. Is that clear or not? ठीक है, ये डेरिवेशन रहने देते हैं. ठीक है, is that clear? So anything, any vector which have any kind of a component along x axis, हाँ हाँ समझ गया समझ गया. Good morning Devans. So any kind of a vector which has a component along x axis and y axis, it will be represented as modulus of vector a cos theta and modulus of vector a sin theta. ठीक है. अब जैसे मान लो एक लास्ट एग्जांपल है, उसके बाद अपन इसको बंद करेंगे. Tomorrow we'll do much more resolving of vectors and the addition of vectors and then we'll move ahead. ठीक है. तो मान लो अगर कोई वेक्टर क्वांटिटी है, इस बार वेक्टर ए दिया हुआ है, सेम वेक्टर ए है, जिसका लेंथ होगा मॉडुलस ऑफ वेक्टर ए, बट दिस टाइम एक्स एक्सिस के साथ एंगल नहीं है, थीटा इज गिवन विद रिस्पेक्ट टू वाई एक्सिस. So this is x, which is I cap. This is y, which is represented as j cap. But this time angle theta is given with respect to y axis. So when I will draw the triangle, I will have to draw with respect to y axis or not. Reply nahi aaya. Yes, isn't it? So then the cos theta component will be along y axis while the sin theta component will be along the x axis or not. अरे कुछ तो बोल है ना, क्योंकि अगर ये थीटा है तो ये लेंथ कितना है? मॉडुलस ऑफ ए वेक्टर sin theta, and ये लेंथ कितना है? मॉडुलस ऑफ ए वेक्टर cos theta, because I know my hypotenuse, so I can write in terms of cos theta and sin theta. Is that clear? So ध्यान से देख, ये बेस भी क्या हो जाएगा? मॉडुलस ऑफ वेक्टर a into sin theta. तो ध्यान से देखो, अपन को वेक्टर a मिला या नहीं मिला? अपन को वेक्टर a मिल गया यहाँ पे, है ना? It has a length. Then once again I can write my vector a. Vector a has length along x axis how much? Modulus of vector a into Sin theta I cap this time plus modulus of vector A into cos theta j cap. This is my vector A. So when you change the angles, the components actually changes. One becomes sin theta, another becomes cos theta. Is that clear? Balaks, is this clear? रिप्लाई नहीं आया. नरेश समझ में आया? मजा आया? सो इस चीज को बोलते हैं रिजॉल्विंग ऑफ वेक्टर और रेजो इसको भी बोला जाता है समटाइम्स रेजोल्यूशन ऑफ वेक्टर्स which provides us the idea that how vectors band will be created. If I know my specifically only the length of the vector and the angle made with the x-axis, then I can have the two components along x-axis and y-axis. One is called as horizontal component. This component along x-axis is known by a name as horizontal component, and y-axis component is named by a name of vertical component. So you can write over here that horizontal component is a cos theta and vertical component is a sin theta. Is that clear? Are you able to get me? मजा आ गया? चलो तो यहाँ पर अपन हम इस वीडियो को अब खत्म करते हैं and tomorrow we'll do much more resolutions, like we'll be bring 5 to 6 vectors at one time and then we'll find horizontal and vertical and then we will